Welcome. My name's Talfan Barnie and I'm a remote sensing specialist at the Icelandic Meteorological Office.
Hi, I'm Melissa Pfeffer. I'm an atmospheric volcanologist. I work for the Icelandic Met Office, or Veðurstofa, as it is in Icelandic. My job is to measure the gases that come out of the Icelandic volcanoes, both in between eruptions, which is the vast majority of the time, and during eruptions. And so most of what we're going to be showing you in this video today is measurements that we make during eruptions. So when we're deciding how and when we should do the traverse for the DOAS, what we look at first are the weather conditions and the winds. So we need the winds to be strong enough that we have a good cohesive plume. And like ideally, it's not so terrible that it's, dangerous for us to be driving. So our first tool is we look at the dispersion model. And so the dispersion model, it's only showing us the SO2 that's at the surface because the dispersion model is optimized for the usage of the people who can be affected by the eruption. So this isn't showing all of the SO2 in the atmosphere, this is only showing the SO2 at the surface. But this combined with the winds gives us a good idea of where we need to go in order to measure the gases. So with the traverse, we're measuring all of the SO2 in the atmosphere that's directly above the telescope. So right now we are here in Reykjavik and we're going to drive to about here to Vatnsleysuströnd, where we will set up the instrument and then you will see that. And then we set it up and then we're going to drive here. In order to transect the gases, we need to go from clean sky to polluted sky to clean sky in order to calculate the emission rate of the SO2 from the eruption. So we're setting up now to do a DOAS traverse, which is where we're going to be driving in the car with a telescope connected to the DOAS spectrometer so that we're able to go from clean air to polluted air to clean air in order to calculate the emission rate of the SO2 coming from the eruption. So the first thing that we do is we mount a telescope to the top of the car. So here we have a telescope attached to a metal frame, and we tape this to the top of the car. We want this to be vertical. So as we're driving, we want to be looking straight up into the sky and measuring the SO2 in the vertical column where we are as we're moving. How we attach it to each car is different depending on the car, but having these frames and having the ladder makes it much easier to attach the telescope to the car. But we can be quite adaptive to whatever car we have available. We want as little vibration as possible to keep the data cleaner. So we just want this to be as stable and non-wobbling as possible. So the fiber optic cable connects to the telescope, and then it goes through the open window to Talfan. So this is the spectrometer. This is what's actually measuring the disturbance to the ultraviolet light that's caused by the SO2 gas. So this is what's actually doing the work. So Talfan connects the fiber optic cable to the spectrometer, and then I'm giving Talfan two cables. So one of the cables is a GPS. The GPS is going to mark where we are as we're making the measurements, and then the other one is just a cable that connects the spectrometer to the computer.
Okay, so we're starting the software now to capture the spectra and tell us how much SO2 is in the atmosphere. I'm just going to have to think about that for a while. Okay, here we go. Okay, we just need to make sure that we are saving things with the right date. So it's now the 9th. We're using the right spectrometer. We need to make sure we've got the serial number in the file name. That is the right one. And then we need to make sure that the file name has also got the right telescope. Are we using the thin or the thick telescope?
We're using thick.
Thick, okay, so we leave it as thick, and then this is 00 to start. And the date is the 9th of July. So we're ready to start when you are. Okay. So I'm going to press start now to begin collecting. and it tells us that we're starting. And then the first thing it'll want will be a dark spectrum. So cover the spectrometer.
So we're going to cover the telescope completely in order to get a dark spectrum. So something that works quite well is your phone. If you take off the cover, and then you need to make sure that you have a very good seal on top of the telescope. You want to make sure that no sunlight is sneaking in around the edges. You don't want to use your hand, for example, because the sunlight can go through your hand. Covered.
It's complaining about the dark spectrum not being completely dark. But I think it looks...
Just hit okay.
Just hit okay.
Yeah.
Okay, so point to the sky. And you can see the green line is showing us the spectrum that the spectrometer is measuring of the ultraviolet light that the telescope can see directly above us. And then here in red, this is the total amount of SO2 in the atmospheric column being plotted as these vertical red bars.
So what we're looking for in this to know that we made a good dark spectrum and that we're measuring good atmospheric amounts of SO2 is when we look at this baseline before we start driving, we want to make sure that it's that the average is around 0. So we want to see the red bars both above and below the 0 line, and we want it to be that it's not too high value. So plus or minus 20 is fine for using the thick telescope. And this is good because we have even distribution around the 0 line, so we're ready to start driving.